Good day, everyone. My name is Abdullah. Today we'll be looking at gas fee optimization. So basically, when you hear about gas fee, it's just the amount that is charged whenever you make any transaction on blockchain. So how do you optimize some gas fee? We have several ways to do that. Um, Here, I would just be showing or walking you through some articles on, how we can actually optimize um, gas fee on Ethereum. So basically, like I said earlier, I said we have a couple of ways of saving um, gas fee. So let's just look at the first one. It's called short circuiting. So it says it's a strategy we can make to use when an operation makes use of either or and. So the first one is or, the second one is and. Okay, let me highlight it. This is or, and this is the other one is and. Okay, sorry. So this pattern works by ordering the lower cost operation first so that the higher cost operation is skipped. So basically, what this is saying is that imagine you trying to run two functions. So let's say in the first instance, you wrote a function that says once function A should run, function B should not run. So if that is the case, you would try to place the first function, the function with a lower cost, you place it in the first place, so that once that is true, it will skip the um the function with an higher cost. So it is not certain that the second will not run. It's just like an if-else statement saying if this is true, fine. If it is not, move to the next listing. So if it is true, it will just run the lower costs and voila, you saved yourself a transaction fee. So another one is unnecessary library. So I think one Solidity version is still 0.2, 0.3. I think it has issues pertaining to arithmetic. So part of the library that is being used then is called I think safe mass. Yeah. So it is just a way to safely calculate any data or any input. So right now, Solidity has upgraded its version. I think they have a higher version than 8.9 like that. So this type of current version doesn't have arithmetic problem. They've actually taken care of that. So imagine you using Solidity 0.8 and still trying to make use of safe math. So it's just like you're using an unnecessary library. So that also cost you that's also increase your gas fee. Like I said earlier, look at what they said. They said libraries are often only imported for a small number of uses. So meaning that they can contain a significant amount of code that is redundant to your contract. So instead of you doing 2+2, you're now importing safe maths and doing safe maths of that. So it's just like redundancy. So your gas will also skyrocket. Okay, so okay, let's just look at this one. It says in Solidity, some data type are more expensive than others. So it's important to be aware of the most efficient type that can be used. So here are a few types of Solidity data type. So it says that when you are making use of type on an unsigned integer, it can be used in place of string whenever it's possible. So type OnIns should be used in place of type string whenever it's possible. So it's actually saying that we can actually use type int whenever we want to like make string. So I think basically what they are saying is, imagine you trying to like use, we know an integer is a number, not letter. So when you're making use of an a number, a string number, it is preferable that you actually make use of unsigned integer. So it will actually save you costs. So it's also being said that type on int with with 256 storage take less gas fee than unsigned integer of 88. So basically, unsigned integer 256 and unsigned integer, it's both of them are actually the same, but storage differs. So the amount of um the amount of storage one can take is actually different from the other. So they said its type bytes should be used over bytes, an array of bytes. So I think the last one says if the length of bytes can be limited, use the lowest amount possible from bytes one to this. Okay, and also it says type byte is cheaper than to use type string. Yeah, so if you want to store like something on your blockchain, I think there's a way you can actually um convert a string to bytes. So you can actually save bytes on your blockchain, and probably if you want to retrieve it, you can convert it back to string. So obviously, bytes are cheaper than string. So okay, dead code. What's meant by dead code is like okay, we basically know that when we're using sorry, it's basically means an unsigned integer. So it's saying that any integer that you are sending down will be basically positive. Like it can never be negative, except if we make use of int. Do you get? So imagine me now writing an if else statement saying if x is less than 1. Logically, I know that this code will not run. Why? Because I'm sending an unsigned integer. So x can never be less than 1. Yes, x can be 0, no problem. But x can never be less than 1. So you see this from line 2 to line 7, um it will not run. So I don't want it's just like you writing an unnecessary logic that you know it will result to false. So imagine, okay, your code is now running now. When your code runs line 2, once it checks that, okay, if x is less than 0, is it true? Is x less than 1? Obviously, it will be false. Then line 3 to 6 will not run. That's why I said dead code is a code that will never run because its evaluation is predicted on a condition that will always be false. So we know that condition line 2 will always be false. So line 3, 4, 5, 6 will never run. So that will also spike your gas fee. So I think the last one I'd like us to look before jumping into coding is when you are trying to make use of loop. Yeah. So imagine you having a storage. When I deploy a smart contract, I can actually initialize the storage. Let's say I would declare it an unsigned integer. I can do public or private. Then I can say I would name the variable. Let's say total values, total supply. You get so total value supply. So then I would provide the total supply. So that is just like a storage because I actually stored that in my blockchain. So and let's say I have an array of users, an array of users balance. So you'd want to store like users balance on your smart contract. So imagine me, okay, let's just say expensive loop. Let's just look at this one. Now you're actually looking through you created a loop. So in line 5, it is certain that, let's say the loop will run for 5 minutes. Sorry, 5 times. Let's say x is 5. So the loop will run for like 4 times. So while the loop runs 4 times, it will actually be visiting the norm. That means the number. It will be visiting it. So it's just like it's making multiple calls on a storage. Imagine you making multiple call on database. Imagine how your application will be slow. But let's say you have a caching layer, whereby when I mean caching layer, I'm sorry, I'm not supposed to use this. When I mean caching layer, it's just like a mini database that is faster to access. So we have I think we have Redis and the likes. So imagine you now running this loop now. That means you visit this non-storage 4 times, which would spike your gas fee. So there's a way you can actually do it. You can actually create a memory here inside your function, then store the memory store the storage in your memory. So then you make use of your memory after after the loop has finished running, then you can set back your storage. So when you are making use of data stored on blockchain, try to like switch from storage to memory. It actually helps. It is not that the storage will not work, but your this thing will spike up. So I think okay, this is basically just like the same thing. You get a normal loop. And okay, like, look at what I said now. Yes. So basically, line four is just like a memory, and on int. Sorry, I said memory, and on unsigned integer. So you just like initialize this term. So then you saved the number there. So you basically created another stuff. So you are actually using this unsigned integer, which is term. This is what you are visiting now. So you are not calling this number multiple. Let's say this for loop will run 10 times. So to no more call this number, but you only call this temp because you've saved the storage here. So to now be calling it every time. Sorry, before the loop runs out. So after the loop runs out, then you can now reset your number, just like you're beating. So basically, you only called this number twice. Do you get me? The initial line 4 that you set it, and the initial line 8 and the final line 8 that you reset. So unlike this, you are calling if the loop will run 10 times, it will call it 10 times. So you can see that this code helps when it comes to code optimization. Do you get? Okay. Um, okay, let's look at this one too before we dive into coding. So if the outcome of a loop is a constant, then it can be inferred during compilation. It should not be used. So now we say constant outcome, then the number, then we declared a variable, which is an unsigned integer, which is 0. Then we did a loop through. Okay, this is 100. Now we are certain that this thing will loop 99 times. Then we actually like increment this on int and then return the number. So if we are certain that what we are doing is constant, so there's no need of using our storage. Just declare this thing you get. And okay, let's look at loop fusion. Okay, yeah, this loop fusion happens whenever you have two variables that needs looping, and let's say you are provided with two arrays that need to loop through. So once you see that the amount of time that will take you to loop through the first element will also be the same amount of time that will take you to loop through the second. So if you are looping through these two now, like 100 times, instead of you creating two separate loops for them, this is, I would say, this is like repeating code that doesn't really make sense. You can actually make use of one loop. So instead of writing second loop, I can After line 3, I can also write y plus is equals to 1. Do you get? So after that, then you now jump to line 8. So that this is why they said loop fusion. They said occasionally in smart contracts, you may find that there are two loops with the same parameters. Do you get? So in this case, the loop parameters are the same. So it's like the loop parameters are the same. So there's no reason to have a separate loop once the parameter is the same. So repeated computations in loop. So they said if an expression in a loop produces the same outcome in each iteration, so it can be moved out of the loop. This is especially important when the variable used in expression are stored in storage. Okay, so basically we have two storage here now. We have 4 and we have 5. So they are basically storage. So we said repeat computation. So we declared a sum like which is taking the addition of both. Then we say okay on int. Okay, we did our normal for loop. Then we start saving this. Do you get, like, we start saving? Okay, we assume that this is, sorry, we didn't even assume. Initially our sum is 0. So when you are creating a loop, it will keep on recalling it. So this is the first time this thing will run. It will be like 0 plus 4 times 5, 20. So sum with 20. The second time it will run, it will be 20 plus 4 times 5. So it will be 40. Do you get? That's why they said if an expression in a loop produces the same outcome in each iteration, so it needs to be moved out of the loop. So I hope you get. So okay, let's take the last one. Yes, it said when a comparison is executed in each iteration of a loop, but the result is the same each time, so it should be removed from the loop. Okay, so see now, this is a unilateral function. So we have a sum, we run our loop. So I basically know that, okay, and initially this said our I is equals to 0 and I is less than equals to 10. So I can never be 1, 1 and I can never be minus 1. So if x is greater than minus 1, of course, okay, yes, okay, of course, x, okay, the only way x will be less than 1, like the only way x will be less than 1 is when I imagine it sending down 0. Do you get? Let's say I send down 0 as x now. So if I do, if 0 is less than 1, yes, it will run. Do you get? So if 0 is less than 1, it will not do sum plus, sorry, what am I saying? If x is greater than 1, I'm very sorry. So if x is greater than 1, so it will increment. It's just like they're incrementing one by one. So imagine you having this function and you want to run it 4 times. So the first time you supply 0, okay, we know that since it is 0, okay, this condition will count. But imagine you supplying 1 now. Most times it will be, is either x, like most time x will be greater than 1. Do you get? So this is like, yeah, incrementing. So this place, this 4, and this place. So I don't know if you get what I'm saying. So like, it's just like an increment, so you can actually remove it from a loop. Okay, so um let's dive into just like what will I say, a mini coding, just like to show, just like to run everything I've actually like showed you guys. So I'm coming. Okay, yeah, so basically I um just walk you guys through this little smart contract I have here. I'm basically making use of a mad hat you get as my um as a framework. So it's a framework, but that doesn't really matter. That doesn't really matter, sorry. So basically I have an array of fonts which keep tracks of all fonts, um like different types of fonts, sorry. So we have 4 variables that we did. So we did, because it's just like we're using 4 functions, and each function will be stored in different variable to get. So what we basically want to do is like we basically want to like loop through this array, then get the total, like just like the summation you get. So just like the summation of this, yeah. So the first function that would come to our mind is to loop through, then to like keep on adding by the index of the loop. So basically, since when we deploy the smart contract, the array of fund will be initialized, so it will be set to this array of 1 to 10. So let's take a look at the um, um, first function. First function says get total funds. So basically, what we are just doing here is just like we are basically looping through this. So as we are basically looking through this, um we then increment on each loop. We try to increment this total funds on each loop. Do you get? So where this function has error, okay, it's not an error. Where it's like not gas efficient is that on each loop, we will keep calling this our storage here, this our array funds. On, let's say this loop will, okay, because okay, obviously this loop will run like 10 times. Do you get? So that is, we'll call this storage 10 times, then we'll call this total fund 10 times. Do you get? So we are visiting storage 10 times, visit, it will work. Oh, but as you're visiting storage, you basically know that storage is more expensive. Yes, more expensive. Also, memory too is but memory is um it is cheaper compared to was it compared to storage. Do you get? So okay, now we actually, aside from this, we'll still run tests just to like show us the gas consumption. Do you get? So um so someone now try to like create a new gas function, a new function to do that. Okay, so basically what this function 2 does, get total fund 2 does is it initializes a variable here, total funds. Do you get? So on every loop, so once you initialize an unsigned integer like this, the initial value is 0. So imagine you saying this total fund is equals to 0, like on the first loop, 0 plus the first index of the array, then you keep on doing that. So basically what you are doing here is like you are only revisiting this array storage. You know, in the first place, you are visiting both array storage and total funds. So in this one, you are basically visiting array storage. You are still visiting 10 times, but you are not visiting the total funds. The total fund you are using is the memory you created here. Do you get? So after you finishing the loop, you mustn't forget you need to set the total funds, which is this. You need to set it here. So basically, this first function, you visit this total fund 10 times, then you visit this array fund 10 times. But this second function, you only visited this total function once because you are resetting it. Do you get? And you are still visiting this array funds 10 times, or let's say the amount it takes the loop to run, because it's not, you can decide to have more than 10 numbers in an array, or let's say less than that. So let's go back to the let's go to the function 3 now. So function 3 now basically loops through our stuff too. So what this one does is it saves the array inside the memory. So basically I switched, I said earlier that try to switch from whenever you're making use of storage every time, anytime you're making use of storage, when you know that yes, this is my logic, I must make use of storage every time. See, you can actually like minimize your gas fee when you have heavy loop. So you try to like switch from storage to memory. So this 30 get total funds now is basically switch from storage to memory now. So I actually move my storage, which is array funds, and I save inside the memory. So whenever I'm checking through this loop now, so instead of visiting my storage, which is array funds, so I'll be visiting underscore array fund, which is the memory, the one me I just created now. Do you get? So basically, throughout this loop, I'm only visiting. Okay, throughout this loop, I'm visiting total funds, which is a storage, 10 times, or the amount it takes the loop to run, which will cost me more gas fee. So, but I'm not visiting the array fund 10 times. Why? Because I saved it in the memory. So I'm only visiting the array fund once. That is line 33. Do you get? I only visited it once. Why? Because I just want to like save it in the memory. So this, you see this function 2 and function 3, it will still consume gas fee very well too, but it will be less compared to the first function, which is get total fund. Because if the get total fund is just like checking through storage, just like making call to the storage. So the last one, which is just like the best function out of these four, is what this last function does is the get total fund for does is anytime it sees a um a storage, it quickly converts them to memory. So array of fund basically is a storage, right? It converts it to memory underscore array of store. Total fund, which is this total fund. This is total fund. You basically need a storage. Total fund for sorry, we guys know is a storage. So it actually like make a space for it to just like a memory. So basically, what it does now is that when this looping is running, you can see that we are not visiting any storage here. We are basically visiting our memory. So when I'm saying memory is just like something you save in your function and something that like it will wipe off after your function has run finished. But when we're saying storage, storage will still remain in your blockchain. Do you get? So you can see that this thing is saved in memory. My array of fund is saved in memory. So when I'm looking through this thing, I'm visiting my memory, which is underscore array. You know underscore array. When you see underscore, it is memory. Like my name conversion. Yes, when I did underscore, I just like make it a memory. So we're actually visiting a memory. You can see this underscore now is the new memory I created, not the storage. So if this thing should run 100 times, you're not visiting any storage here. You're basically visiting your memory here and this memory here too. So after the loop has run finished, then you now set this is a storage, this total fund for this is the storage. Then you now set it to the memory we created. So this basically this get total fund for visit our storage. Let's count the amount of time it visits it. The first time it's visited my storage, my array of fund 1 gigabit, and the last the another place it visits it is line 45, where it's setting the final data gigabit. So it's just like if the loop should like run 1 million times, I'm just visiting the array of fund once, and you are resetting the total fund once. Do you get me? So let's pretty much try like let's run this stuff. Here I have my um ad hats running. So I would just like to deploy my smart contract to Remix. So I have a Remix code editor, Remix VS Code Remix extension here. So instead of me deploying, I can actually use my extension. I use my interface here. I can deploy here instead of me going to the smart contracts place. They get so okay. So basically, what we'll do is okay. I think I've actually connected it here. Okay, let me disconnect. Okay, now so my local server is running. Let me show you so that it won't be like where did I get my URL? So I'm coming. Okay, where is how that config? Oh, sorry, my system is a little bit slow. I'm very sorry about that. So you can see this is 854 blah 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 blah. So localhost 8545. Okay, so now it says I should connect to a local blockchain. So if I'm using a local blockchain, which in my case, yes, I'm actually making use of a local blockchain, then I connect tickets. So if I, but let's say I'm making use of another um another blockchain. Let's say I'm making use of the mainnet or testnet. Fine, no problem. So this is how the editor works. See now, it detects that network is a local or custom network. So it detects that it's a local network. Dig it. So this is the way the extension works is once it's connected, you try to deploy your you try to compile your smart contracts. Before our smart contracts will be able to interact with our front end, it needs an ABI. So before you get that ABI, you need to compile the smart contract. So here now, I think I've clicked on compiling smart contract. So you would see my terminal, it says compiling with version latest. So it's just like compiling with the latest version of Solidity I use, which is I think 0.84. Yeah, 0.84. So this thing is still compiling. So once it has compiled, I'm basically going to deploy my smart contract, which is that API. So yeah, this is the key that I'll use to deploy. I cannot deploy now. Why? Because my smart contract is still will I say it's still running. Sorry, my compilation is still running. I say smart contract. Yeah, my compilation is still running. So once it's has compiled, finish, it will certainly tell me, or to certainly bring something, pop up something in my terminal that says compile finished or something like that. I don't know. So let's just wait for that. Okay, yeah, I think my Solidity version is 0. See, compiling local or cache version 0.86. So let's assume I'm using 0.2. Yeah, I would need there would be need for safe marks because it those Solidity version has I think overflow or an underflow when it comes to arithmetic. So let's wait for our smart contract to compile. Okay, I think it's compiling. Compiling metadata is modifying, blah, 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 blah. So let's wait for it. Oh yeah, see now. It's saying compilation finished. So once the compilation is finished, then I deploy. So it's saying deploying smart contracts. The name of my contract is gas fee test. So it started. Yeah, so contract deployed. Bam. So let's see now. You basically know that all our smart contracts performs the same stuff, the same function, and they will give the same outcome. So here now I have the gas fee stuff here. Now, so the first okay, let's start with the let's start with the first one. So the first gets total fund, which loops through everything. So once we click on that now, let's check the gas fee now. As you can see now, this is gas used. So the first one that we just loop through everything is using gas of 75064. Let's take note of, you get. So let's visit the second transaction too, and let's see the amount of gas fee that one we used to. Remember that the first one takes a gas fee of 758 something something. So this one now gets 73. They are still performing the same transaction but different gas fee consumption. Why? Because of the optimization we did, the little optimization we did from our storage. So let's visit the third one too. So the third one basically use 732. You can see that the third one is not really different from the second one. Okay, 7345. The second one uses 7315. So the reason why they are like that is because we are still like checking and recording our storage sometimes. So let's now go to the last one. Okay, sorry. Let's now go to the last one, which basically is calling our storage just once. See, this is it. Line 40 basically save the storage into memory. The line 45 basically resets the storage, the total fund value to the one we created here. So let's call this one. Then I believe the gas fee should be small. Okay. So let me total fund. Oh, sorry, I'm calling total fund. I shall see that I'm getting nonsense. Okay, so this is what I want to call, which is get total fund. So if I check this get total fund, so you can see now this is 71639. So I don't know if you recall, the first one I called was 75 something something. Let's even check safe. There's no need of saying. I think you can see now the last one, which is the optimized version of our code, uses 71639. The second to the last uses 73. Do you get? The fourth one uses, as you can see, 7316. Why the first one that we just like look through uses 75. So from 75 to 71, at least that can still like it still saves us a little gas fee. So like I said earlier, there are many ways to like optimize our gas consumption fee. This is just, I say, one way of doing it. So I said try to like remove redundant code that you are sure that um it will not um it will not work. Imagine me declaring an unsigned integer here and now checking if an unsigned integer is less than 0. Everybody knows that unsigned integer can never be negative. It will only start from 0 to infinity. Let's 0, 1, 2, 3, 4. And so imagine me now saying if the number I sent down is less than 0. So basically I'm saying if it is negative, which will never work, it will keep on returning false. So I have many ways of optimizing our gas fee. So this is just the little one. So I hope you all like gain from this. So I don't know, probably another video might be dropping on, I think, another way of optimizing gas fee too. So you can actually like write the complete smart contract, then like try to optimize the first version you wrote, then now see the transaction fee, the gas fee, sorry. So you would see that it will be reduced drastically. You see this 7.1 and 7.5 that you think is small. It is when you keep on making transactions upon transactions, when your user will be complaining that okay, this thing is your smart contract gas fee is high, blah 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 blah. So I think that will be all for this um, today's video. Thank you very much, and goodbye.